Hey, geometry students, let's continue again today with our review packet that we've been working on throughout this week. Don't forget at the end of this week, either on Friday the 15th or the following Monday on the 18th, you'll need to Skype with me. You can do it when you check in for your attendance. You need to show me this completed packet so I can give you a credit for what we are doing. Again, do not turn this into me next week in your work packet that you're going to return to school. This is yours to keep to help you as you're preparing for our fourth quarter test that you will take next week. We're going to pick up today on question 16 on our worksheet. And on question 16, I just gave the basic information up here on the slide. You can read the entire question there. I have a triangle that has these three ordered pairs as their vertices. Point D was located at 4, 6. Point E was 6, 8. And point F was located at 2, 10. Our job is to do a scale factor of 1/2. What did that mean? I'm reducing the picture. I'm reducing each of these ordered pairs by 1/2. So the format that we used on the question for a dilation, it was capital D for dilation. It was the letter O because they were centered at the origin. That was always the case on this question. And then comma K, which was the constant or the scale factor, which we had, which was 1/2. The first point that I'm working with is point D, and that was 4, 6. So all that I did was take half of both of my numbers. So half of 4 was 2, and half of 6 is 3. I did the same thing for the other 2 points. So my dilation centered at the origin, the scale factor of 1/2, my second point 6, 8. So half of 6 is 3 and half of 8 is 4. Last point, the dilation centered at the origin and my scale factor of 1/2, the ordered pair is 2, 10. So half of 2 is 1 and then half of 10 is 5. And that's it. I've given the new ordered pairs that correspond with the dilation of 1/2. Question 17. My three ordered pairs this time are M, -1, 2, N, -2, -1, and P, -2, -3. Now this time the scale factor is 3, which means I'm making the picture bigger. The same process that we just did. The dilation center at the origin, and there's my scale factor of 3. The first ordered pair was my -1, 2. Both of those get multiplied by 3. So -1 times 3 was -3, and 2 times 3 is 6. Moving on to point N. The dilation centered at the origin, the scale factor of 3, and the original point was -2, -1. -2 times 3 is -6, and -1 times 3 is -3. Last point for P. The dilation centered at the origin, scale factor is 3, and then my point is -2, -3. Again, just multiply both of those by 3. So -2 times 3 is -6, and -3 times 3 is -9, and you have given the new coordinates for the dilation that you have in your question. Moving on to question 18, where we talked about our intersecting chords, and you can see the picture there on your worksheet. When we had the intersecting chords, there was a property that we had learned that said the product of each of the individual chords was equal to the product of the other chord. Well, what two chords do I have? What pieces are they split into? This first chord is split into the coordinates or the pieces of X and 15. The second chord is split up into the pieces of 6 and 10. So those are the pieces that get multiplied together. So I did X times 15 or 15X equals the other chord was 6 times 10. Well, 6 times 10 gave me 60. So at 15X is equal to 60. And our job is to find the X. So I divided by 15 and that gave me the X was equal to 4. I could check that quickly if I wanted to. 15 times 4 is 60. And I know that I have the right answer here for the X. Question 19, the same process. My job is to find the X. So I need to multiply the pieces from the same chord in order to get the answer. So what pieces will get multiplied together this time? Well, on the chord that's going kind of diagonal here is the 3 and the 16. Those will come together. And then the other direction horizontally is the 8 and the X. So I just put the part with the X first. So I said 8X was equal to 3 times 16. 3 times 16 gave me 48, and then to get X by itself, I divided by 8, so X was equal to 6. I could check that. 8 times 6 is 48, and I can see that I have the correct product on my question. Moving on to questions 20 and 21, you'll have the same pieces of information that are used on both of these questions. The problem states that the ratio of my two similar figures is 4 to 9. Remember, similar figures, they had the same shape, but they were different sizes. One of them was bigger and one of them was smaller. The ratio that they're giving you of 4 to 9 is comparing the side lengths that we have. So I have a smaller figure that has a side length of 4, then in the bigger picture, the corresponding side is 9. That's what that ratio means. Our first question on number 20, what is the ratio of their perimeters? Well, remember, the perimeters come from the side lengths. To find the perimeter, you just add up all the side lengths together. So what was true about the ratio of the perimeters? It was exactly the same as the ratio of the sides. There's no work I need to do. I just copy the exact same ratio down of 4 to 9. Now on question 21 is asking you for the ratio of the area. Well, area, like we saw earlier with our cone questions, area is always something squared. So how do I find the ratio of the area? I take the ratio that is given to me and I square each of the individual pieces. So 4 squared would be 16 and 9 squared would be 81, and the ratios of their areas is 16 to 81. Let's finish out with 2 more questions today, and these will be the graphing that you have in numbers 22 and 23. The graphing that we see here is the ones that dealt with our inequality, which we had to make the decision on the kind of line, whether it's solid or dotted, then also the direction that we had to shade. Was it above or below our line? So question 22, y is less than or equal to 1/2 x minus 4. This equations are the inequalities already set up for us to graph. Both of these actually are because the y is by itself. The first piece that we used when we graphed was the y-intercept, and that's the constant that we see at the end. The constant at the end of this question is a -4. So from the origin, I went down 4 spaces, and that's the first point that I put on my picture. We're now ready to use the slope. Now remember, we're graphing, so the definition of slope is rise over run. This slope is already a fraction, so I don't have to do anything special. The rise that I have is 1, and the run that I have is 2. So from the y-intercept, I'm going to go up 1 space and then right 2 spaces, and there's the next dot that I put on my graph. Now that we have those 2 dots, we're ready to connect them, but don't just haphazardly connect them. We got to think about how we're going to do that. We look back at the inequality symbol. The inequality symbol that we have is less than or equal to. Because we have the equal to bar, then I do use a regular bar or a regular line to connect my dots. So I use a solid line to connect the 2 dots that I had on my Cartesian plane. The last decision that we had to make was where we were going to shade, whether it was above or below the line. Again, that decision is made from the inequality. The inequality that we have here is a less than. So what does less than mean? It means to shade below. So I shaded below my line, and that would be the final picture that I would give for question 22. Our last problem for today, number 23. Our inequality is y is greater than -2x plus 3. Again, the y is by itself, so I'm ready to graph. The first piece we're graphing is the y-intercept, and that's the plus 3 that I have at the end, so I went up 3 spaces on my y-axis. Now, this time the slope is not a fraction, so let's go ahead and make it a fraction. The slope that we have in this problem is -2. So how do I turn -2 into a fraction? I'm going to make that -2 over 1. The negative sign only applies to the 2, not to the number 1. So from my y-intercept, I'm going to go down 2 because the rise is -2, and then right 1 because the run is +1. So down 2, right 1, there's the next dot that I have. We're ready to connect the dots, but don't just connect them. Make sure you're thinking. The inequality symbol that we have this time is just greater than. There is no equal to bar, so because you don't have the bar, you don't use a regular line. We're going to use a dotted line this time to connect the 2 dots on the Cartesian plane. Where are we going to shade? This inequality is a greater than. What did a greater than question mean to shade? It was above in your problem. Again, let me know if you have questions on the problems that we've been working with so far this week, and then over the next 2 days, we'll go ahead and finish up our packet together.